Hi Doctor, my name is Wong Chin Kang, can call me CK. My mention number is A180110. Today, I will do the presentation for the subject BEV20501 Electrical Engineering Lab 1. The experiment 9, AC voltage measurement using oscilloscope. I'm from section 9-6. There are 4 group members in our group, which is Siti Nurul Jana binti Yatim. The mention number is AE190108, and the second one is Mawichi. The mention number is AE190085, and the third one is me. And the last one is Tufali bin Zulkifli. The mention number is C210161. And now, I will continue to the presentation for the activity 1. First, we construct the circuit according to a datasheet given. First, we put the AC voltage source. After that, we put a resistor, which is the 100 ohm, and we put another variable resistor, which is the 1 kilo ohm. After that, we do some arrangement, and since the variable resistance is 100 kilo ohm is given in the datasheet, and the voltage given is the volt for 14.6, and the hertz is the 50 hertz. After that, we connect it to each other in the series. After we done the connection, we put the multimeter connect to each component. After we done the connection to the multimeter, we connect it to the oscilloscope. That's all for the circuit connection. After done the circuit connection, and now I will show the VSC supply. First, we run the simulation first. After that, we double click the multimeter, and now we can see the reading of the multimeter is 0.32 volt. This is the VRMS. And now I will show the output of the oscilloscope. And we pause it first, and we bring to the front. We can see in the oscilloscope show us a graph, and this graph is the 10 volt per division. And we can see got one peak, and we bring to the peak, and we can see is the voltage reading is the 14.6 volt, and the V peak to peak is we multiply by 2, and we can get the V peak to peak, and the frequency is already given as a 50 hertz, and we use the frequency to calculate the time, and the calculation already mentioned in the lab sheet. And my friend will continue to the presentation for the VVR1 oscilloscope. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you to my friend. Okay, now we will continue the presentation about the VVR1. Okay, first I will run the simulation. So after I run, we wait for the minute. Okay, after I run, we can look at the VRMS, which is the VRMS is 9.383. So this is the VRMS. Next, the result on the oscilloscope. So this is the result from the oscilloscope, and this is the V peak. So this is the V peaks, and the time per division, the watt per division, this is 5 watt. So this is the simulation. This is the V peak to peak, and the watt per division 5 watt. So the calculation value is I have done at the lab sheet. That's all from me. Thank you.
Assalamualaikum Doctor, my name is Siti Nurul Jana, and I will continue with activity 1 for the R1. So this is our circuit. So now we run the simulation. So for VR1, the multimeter reading is for VRMS, which is 938.515 millivolt. So now I'll show the graph. For this graph, 1 division equals to 2 volt, and this graph is a sinusoidal graph since it is AC voltage. So this is for 1 cycle, and this is the peak of the graph. The value of peak voltage and peak-to-peak voltage was calculated by applying Ohm's law, and it already stated in the report. So that's all from me. Thank you.
A very good day to Doctor. My name is Mamichi. Next, I will continue the explanation for simulation in Activity 2. In this Activity 2, we will use back the circuit that we have conducted in the Activity 1, and we just replacing the value for the variable resistor. In Activity 1, the value for the variable resistor is 1 k ohm or 1000 ohm, and this is the setting for the Activity 1. In Activity 2, we can adjust the variable resistor to 20%, and this means that the variable resistor is in the 2000 ohm. This is because the 1 k ohm times with the 20%, and you will get a 200 ohm for the variable resistor. And the components that connected is same as the connection in the Activity 1. And next, we can run the simulation, and we can observe that the value of the voltage that across the resistor R1 and also the variable resistor. And we can see that the 3.441 volt, which means that the RMS value for the voltage is the voltage that will across the resistor R1. And for the variable resistor, the voltage is 6.882 volt in the RMS value, which means that the voltage will across the variable resistor. We can also observe the waveform from the oscilloscope 1, and we can see that this is the waveform, and we can adjust the scales to 2 volt per 1 division, means that the 1 division is in the 2 volt and in the AC waveform, and we can see that this is the peak voltage, which means that's 4.87 volt for the peak voltage that will across the resistor R1, and for the peak-to-peak voltage is the here until here, which means that maximum until this one is the minimum is the peak-to-peak voltage. And next, we can observe the waveform in the oscilloscope 2, and we can set that the scale to 5 volt per 1 division, means that the 1 division is representing as a 5 volt in the AC waveform, and we can observe that is a 9.74 volt for the peak voltage that will across the variable resistor, and the peak-to-peak voltage is the maximum value to the minimum value. Besides, for the simulated value, we can also using the manual calculation to compare with our simulated value. And firstly, we can using the Ohm's law, which is V equals to IR, to get the current that will flow across this circuit. Since that this is the series circuit, therefore the current is same across the resistor R1 and also the variable resistor. After that, we can apply the Ohm's law, which is to calculate for the voltage that will across the resistor R1, which is the peak voltage, and we can also calculate the peak-to-peak voltage by using the 2 times with the peak voltage, and we can get the peak-to-peak voltage, and the RMS value of the voltage, which is using the VRMS equals to the peak voltage divided by the square root 2. And same goes to the variable resistor. And this is the presentation for the Activity 2. Thank you. And this is the presentation for the simulation of Activity 1 and Activity 2 from the Experiment 9 from our group. Thank you.